Okay, so welcome. For those of you who don't know me, I'm Baptiste Favre. I work at BlaBlaCar as Ops Lead. You can find me on Twitter and GitHub and IRC since I have the same nick. So, a quick word about BlaBlaCar first. Who knows about BlaBlaCar here? Oh. That's great. Sorry? History of the company name? Yeah. So a quick word about BlaBlaCar. The company was founded in 2007. It's basically a marketplace where a driver can offer their free seats so that they can share their ride cost. When I joined the company in 2013, we had 5 million members. And CTO came to me and told me, okay, we have to redesign our monitoring. We were using Nagios at this time. And your target for the monitoring in 20 million members. It was quite basic monitoring. I started working with Zabbix since I already knew it. And 6 months later, we had 7 million members. CTO came back to me and told me, the target has changed. You have now to monitor for 50 million members, and you have also to be a lot more accurate and precise in your monitoring. I was fine with that. In 2015, last April, we reached 20 million members. Okay, that's the company as we are today. We operate in 18 countries and have 12 offices around the globe, including India here and Mexico here. Of course, as a guest, CTO came back to me another time and told me, no. It's 100 million members now, and you have to be very, very, very accurate. I was fine because, in reality, my target is 20 million members, or 200 million members, sorry. So, how do we monitor 1 billion kilometers of monthly ride sharing? This is actually a true figure, since this is kilometers our members shared during last July. Of course, we use Zabbix. And the idea is to monitor pretty much everything. That's why we have currently 300 hosts. We have 30,000 items. We have also around 400 new value per second, which is not that much, but we operate a Zabbix server on a virtual machine with only 4 gigabytes of memory and 4 CPUs. And for that load, basically our Zabbix server never goes over 0.5 as load average. So, how do we achieve it? Basically, you need to define first and use standards. We choose that kind of standards. The idea is that the Zabbix server on the left will trigger our probe execution on the client via Zabbix agent active items. When the script is launched, it will prepare and send all information from, for example, your database, and items will be sent as trappers, so in sort of bulk mode to the server. And then, so that we can have a feedback loop, the exit code of the script is sent back to the server via the Zabbix agent. Our exit code are also standard. It goes from 0, meaning everything went fine, to 4, meaning that we had an issue while sending the data to the server. On our server, we developed probes, and we used 2 languages. Our probes use either Python or Java. I will detail each of them a bit later. We use low-level discovery wherever you can, and we use always trapper. So the idea basically is to have only 2 zabbix agent active items per template. All other items use the type zabbix trapper. So the Python part, I developed a Python module called python-protobix. The idea is to use trappers and low-level discovery everywhere, or at least almost everywhere. The first time I talked about this module at work, someone told me, yeah, that's a funny name, it sounds like a drug name. Well, actually, since zabbix claims to be the best sleeping pills, it could have been, but in fact, no, it stands for protocol zabbix. So, python-protobix started as a personal project. It became the cornerstone of our monitoring at BlaBlaCar. It's available on GitHub, my GitHub account, and also on PyPy for those who prefer using it. Here is a quick example of low-level discovery. It's a very simple Python script. So you import the module here, you instantiate the container which will store all the item. You create an item. Of course, this is a sample script, so you have to put your own logic here, but the idea will remain the same. You add the item to the container, and once you're done, you just send it to the server. Same example to update an item. It's basically the same. The only things that change is the type of the container, which will be used to format the data before sending it to zabbix, and the item definition. I will give you a quick example, one with RabbitMQ and the other one with MariaDB. With RabbitMQ, we use low-level discovery to discover each vhost and queues, which allow us to define only item prototypes and dynamically create items for every new queue that could be created. We also use low-level discovery to indicate some thresholds, meaning we can modify the triggers depending on that thresholds. That's very useful because in RabbitMQ, when you have a lot of queues for asynchronous messages, maybe you don't want the same thresholds for 2 queues. The only way we found to achieve it is send thresholds via a low-level discovery. When we update the items, we basically get message number in out ratio so that we can know and can be alerted if RabbitMQ is getting late. And also, who is master, which node is master for the queue, because we use RabbitMQ as cluster, so every node have the vision of every queue. And to avoid duplicate talent, we have to know which node is master for a specific queue. On the right, you have the item prototypes that we define for each queue. For MariaDB, we use low-level discovery in a slightly different way. The most classical one is replication, because latest version of MariaDB support multi-replication, and you don't want to create them manually in Zabbix. So it's very convenient to use low-level discovery. But we also use low-level discovery in a more sort of binary way, just to know whether a specific option or storage engine is enabled or not. As an example, we are able to discover whether Galera, which is a sort of cluster mode for MariaDB, is enabled. And if it is, it's just a simple low-level discovery macro called plugins. If we have Galera in it, then we will create all the required item here. And we do the same with some storage engines. When we update the value, well, basically we try to get pretty much everything for the MariaDB. Some items are well known, and you know that this is important, but some other, especially with the latest version, sometimes you're not sure whether a specific item is interesting or not. So our policy is to get it. Maybe one day we will find out if it's really interesting or not. So we have protobix enabled probes. Currently it's not certain, I think it's 16, but we have some available. We have more to come, like Redis, Dynamite, and Zookeeper, and they also are available for free on my GitHub account. For the Java part, the idea was to use the best tool to monitor specific technology. And basically, sometimes Python is not always enough. So one of our architects at BlaBlaCar, Arnaud Lemaire, developed jmx-zabbix, which is basically a library which will connect to JMX, so get the metrics from the JMX, translate it into Zabbix items, and send the items as trappers. jmx-zabbix can be either embedded inside a Java process, and we use this way to monitor our internal Java daemon. And it can also run as a separate service aside any other Java process, and we use this way to monitor our Cassandra and Elasticsearch nodes. You just need to add a sample configuration file. So you indicate the host name, and you should be careful to use the exact same name which is used in Zabbix. Define also a push interval seconds. Here is 60, meaning the jmx-zabbix will send the trappers every 60 seconds. We also, when the connection fails with the Zabbix server, you can also keep the items in memory. So we allow up to 10 failed run to be kept. And when the connection is back, then the jmx-zabbix will try to send all the items. A second configuration block is for Zabbix part. Indicate the host name or IP address of the Zabbix server and the port. Then we have the JMX configuration, connection configuration. And finally, the mapping between the JMX metrics and the Zabbix items. So for example, here you have Cassandra status failure, which is the Zabbix item name, and it's mapped to the JMX metric org.apache.cassandra.net and so on. And some key can expose multiple value and some aggregated value. So you also can specify here which specific value you want. Okay then, so we got our items. Basically, most of our 30,000 items are collected every minute. So we have them. But having multiple items without anyone to look at them, it's not very convenient. We decided to use Graphana at BlaBlaCar because our developers are comfortable with it, and sometimes the Zabbix UI does not provide enough flexible criteria to build screens. So we used Graphana. Basically, Graphana, you can do things like that, and you use Graphana with a Zabbix data source developed by Alexander Zobnin. And when I opened this setup to a limited number of users in BlaBlaCar, I got 10 dashboards in 2 days. So that was really great. And the Zabbix data source uses the Zabbix API, of course. Here is an example of what we built. It's a MySQL dashboard. So on the left here, you have a group graph, meaning you select a group of server, and you have all the MySQL item for every server. And if you want to look into a specific host, you just have to select in the drop list here, and it will be displayed here. Very interesting. Another example is for our asynchronous messaging, so RabbitMQ. The same ID. We have the message count for all queue in a specific vhost. So this is a vhost, another one. And when you want to investigate a specific queue, then you just have to select it here in the drop list, and it will be displayed here with the count message here and the activity, the status, the different status of a message in this queue. And that's very interesting to very quickly see why something is going wrong. On a more global level, you can also use a dashboard based on dashing. Dashing is a Ruby-based dashboard. We got some caveats. Of course, you have to fix it, because if your CTO notices, it's not good. Yep. So our experience is you have to be very careful with plugins and templates synchronization. Some of our plugins grab everything, every information they can find. So I don't specify in the plugin a list of information. I will work through all the information provided by a Redis server, for example, and get all of them and send. Is that great? That's allowed to implement the probe quickly. But if your template doesn't have the item declared, then the information is lost. So you have to be careful about that. Also, you should really use and configure Zabbix using your configuration management system, either Chef, Puppet, Ansible, whatever. But basically, when you use a configuration management system, we use Chef, and Chef is the best place to know which software is running on which server. So is the central point to be able to configure Zabbix, to use a specific host in a specific group, to apply templates, and so on. So you really should do it. Also, another funny things we had at the beginning, we used short names in Zabbix, and one day we decided to switch and to use FQDNs because we wanted to open some other data centers, and so basically we had to use FQDNs. So that's great. The problem is we just forgot to update our probes, which used short name. And when you send the trappers on behalf of a short name host, and that host is defined with its FQDN in Zabbix, it doesn't work. So information is lost. So what we did is that to check the plugin and templates synchronization, we just had a version number in the probe and in the template, and this version number is sent via trappers. So it became also a sort of heartbeat, meaning we just added a trigger with no data function. If you don't have any data for the plugin version for 10 minutes, then we have a problem. And it's really efficient. What next? What I miss in Zabbix? I don't have my notes. Some feature which has been announced, thinking of prediction, I guess it's the first one, SSL communication, the last one, and in the middle, yeah, I know, it's a scalable backends. We need to be able to keep, we would like to keep detailed history for a long time, and currently, basically, we can't. So I'm really waiting for that. Some other have, as far as I know, not be announced, but I don't know anymore. Well, I see Alexei is writing them, so I guess I will have an answer. Now, the per item maintenance, I heard of it last year, but wasn't able to find the code. I don't know if the guy who implemented it is here, but I really would like to have the code. And the last one is anomaly detection, and that's why we need to keep a long history. Finally, now you can wake up. It's almost lunchtime. 3 takeaways: define and use standards, use low-level discovery and trappers, and really visualization is critical. Because if nobody visualizes your items, basically your item is quite useless. And now I'm available for questions. Thank you.
I have a question regarding this low-level discovery.
Yes.
And I believe you are using it very well. I have a question. First, the question is regarding like the trigger prototype. If I have to customize the triggers value in the low-level discovery, like in a one item prototype, the trigger prototype values to be customized. Is it possible? Have you done it?
Okay, you want to change the threshold, for example?
Yeah, according to the server, according to the our expectations.
You can do it. Oh, at least we do it. The web, where is it?
I saw that you have shown that.
Yep.
But
we do it here, meaning when our probe discovers the queues on the RabbitMQ server, okay, it will also load a configuration file in which we indicate, okay, this queue has a specific threshold. We have default one, of course, for example, 1,000 messages in queue. And this will be the default value sent via a low-level discovery. But you can specify that specific queue, I don't know any name you want, won't use 1,000 messages as a threshold, but 10,000. Because you know it can happen if you have a batch generating messages. You can have a high number of messages in a short period of time, but that's a normal behavior.
But then it's kind of like a fixed value. Then we have to say that this has to be, like this queue has to be this value or this. And
the way we use it is that the RabbitMQ queues are created by the developer. Okay, so by default, the threshold will be 1,000 messages. If they know they will need to higher it, they just tell us, and we adapt the configuration file. If not, okay, maybe the trigger will raise an alert, but
yeah.
that's the game, and you can adapt it afterward.
Probably you have given an answer of my second question also, because my second question was that if you want to skip some processes in the low-level discovery for some machines, like it's the same low-level discovery processes queues running on the all machine, on the 7 machines. But on a one machine, if you want to skip some of those processes, like so I have to disable it. I have to disable the low-level discovery and then make it a separate item and a prototype, a trigger for that. So is there any way to avoid it apart from changing in the configuration? Because configuration means like you have to, it's a fixed value in it. It's a
you want to blacklist some information?
kind of.
Kind of, okay. You can do it with a RabbitMQ plugin, because the configuration files support some regular expression, so it's quite easy to hide some queues. You don't want to monitor, but you were talking about processes, I think?
Yeah, processes is like also, like each process made of one queue, so like it's a kind of hiding some queues or like some processes for that.
If you want to hide some queues, you can use the configuration file.
But just for on one server, not on the rest of the 6 servers. It's like that. Like
with your configuration management system, you can also deploy different versions of the configuration file.
Maybe I think the question is about to change it manually later. So you decide, okay, I don't want to monitor this specific process, and you change it manually. No, at this moment it's not possible. It's not possible, but we are absolutely aware of this problem, so I believe it will be addressed. Not in 3.0, probably in 3.2. This is one of our top priorities. Yes, we're absolutely aware of this problem.
I have one more question. Sorry. If I need the value of like which is displayed on the as a result, like I want a calculated value of trigger threshold. Like a result of the trigger threshold has to be the calculated value. Suppose like it's getting a it's actually I can take an example. If it is getting a value of age is like 6, 7, 8, but I want to display the average age is 5. It's like calculation in the item value. So do I have to do it with a script? Am I clear?
I'm not sure I got the point, but
okay.
I'm sorry.
In the triggers, when you mentioned that threshold value, like I can take an example if it's a cycle time of something, and I want to display the sum or the average of that cycle time, the values which we are getting it from this script, or which we are getting it from the item. Is it possible to calculate the value in the...
You can apply some functions on an item in your trigger expression, so
But it's not...
you're able to you're able to calculate an average value and compare this value to your thresholds. But I don't know if you're...
Maybe I will take this later on. I will show you an example and probably with this.
Okay.
We are doing it with a script.
A solution could be to create a calculated item, which will store the results of the average function, and then you will use the calculated item for display.
Yeah,
that could work.
We are also doing. We are calculating the value and then we are displaying it. That this is the current value of it. But there is no way of doing it in the triggers then, like calculate that value in a triggers or some programming kind of.
If you have your calculated item and this item value is the average of another item, then you just have to define the trigger on your calculated item instead of the original one.
Yeah.
Okay, we have a question here. I am the guy who developed the item maintenance you refer in your presentation, so you're welcome. I can send it to you. But actually, it's not item maintenance, it's trigger maintenance. That is, we disable the trigger during a certain period. Is it what you want? Or?
Basically, I think this could work because either you create maintenance on a specific item, or but the one solution is to define a maintenance on an item, and the other one is just to disable the trigger for a specific period of time. So I want your code.
The question is about what do you think if from today we are starting the open initiative to create an open monitoring protocol led by zabbix, maybe, yeah? And all the community will share the knowledges how to monitoring and logging will be constructed. And in 1 year we construct the protocol that will be mainly shared for all other types, for Java, for Python, for other types for business monitoring. So can you explain your opinion for this?
Maybe I'm not the best guy to answer. Maybe Alexei would be, but my feeling is, why not? The problem is zabbix heavily uses JSON messages, and as far as I know, other monitoring products like Nagios and others don't. So why not? But I think it will be quite hard.
Hi, I have a question about collecting jmx metrics. You said you use trappers for it, and my question is, why don't you use zabbix Java Gateway? And I'm asking because we use we collect this metric the same way, and the reason why we do it is because zabbix Java Gateway wasn't available when we developed it, and I'm wondering if it's any danger with moving to zabbix Java Gateway from performance perspective.
Okay, I haven't tested that much zabbix Java Gateway, so it's the idea was also to have the same workflow for our Java apps and our other software like Nginx, like RabbitMQ, like MariaDB, and so on. And this is this was very important topic for us because, as you see, our activity increase quite fast, and so we have to hire a lot of people. It's basically much more easier when you have to explain a newcomer a unique way of collecting data, even if it's done with different languages, but the workflow is the same. Instead of having, okay, so for this part, we will use Python. For the other part, some Perl. And for Java, you see, we wanted to use the same way to monitor everything. That's really the main reason.